Shall I just get going then? Right. Okay, so this is the kind of squishy bit at the end of the meeting where I'm going to entertain you for about 30 minutes with some pretty pictures and some interesting stuff of what's happened in the sky over the last few months and what's going to happen over the next few months. So hands up everybody who's seen Venus so far in this apparition. So a pretty large number. You'll know that it's at a fairly far south declination at the moment, so it's kind of scurrying along close to the horizon, but it will be becoming easier to see later. This is a lovely picture of 3 planets here. So you've got Jupiter down the bottom here, Venus, and Saturn's just up there, and of course the crescent moon. So this was, when was it, 29th of December, so just at the end of last month. On the odd occasions we get clear sky in the evening, just go out, look to the west, very low down Venus, but it'll be getting higher in the sky, and I'll come back to that in a minute. So normally in these sky notes we start with this fascinating object at the centre of the solar system. Sorry, Lynn. This is, of course, our sun, which is, Jupiter may be the biggest at everything planet-wise, but obviously the sun is the biggest in our solar system, and it generates all of its magnetic field and solar wind and everything, but it manages to do all of that at the moment without actually generating any sunspots, which is a bit of a shame if you're into solar observing. But of course you can use hydrogen alpha, and there have been a few prominences recently. This rather nice one by David Strange a couple of days ago, coming out from the limb of the sun. And of course, all of that material that comes out of the sun, the solar wind, interacts with our magnetic field, which is definitely fairly puny compared to Jupiter's, but produces some very nice displays. And Gordon Mackey up in Scotland always manages to get some fantastic photographs. I like showing them at the Christmas meetings. They're just so good. This is polar star trails with an aurora thrown in for good measure. And he's actually illuminated that cairn in front with an LED light just to get a really nice effect. So, you know, astrophotography can go all the way from sort of really deep scientific and technical images of the sky to something like this, which I just think is an absolutely wonderful image, just capturing the whole beauty of the night sky. If you look at this closely, there is a satellite trail in it, and I'll come to that in a minute, as you might imagine. But I won't say anything nasty about Elon Musk because he can get quite angry and he might be watching the live stream. Anyway, yeah, so we still get reasonably good aurora, even though the sun's not very active at the moment. We're still getting a lot of good aurora. This is one of those ones that Dennis Brzezinski managed to photograph from up in Tarbert Ness in the north of Scotland. Dennis often complains about the light pollution from his aurora. They kind of distract him from the most important thing he should be doing, which is actually imaging comets. And I know Dennis is watching at the moment. So, you know, all these pretty pictures of aurora, but he does get some wonderful aurora. I've been up there many times. I've never actually been lucky enough to see one from his observatory, but he certainly gets very nice views of the Northern Lights. Of course, you can only do that when the sky is reasonably dark, and we have our own huge natural source of light pollution, but which can also be a really interesting object to observe. But for various things that I'm going to talk about a little bit later, the Geminid meteor shower, for instance, the moon is a real problem. So just looking at the dates on here, we have a new moon coming up on Boxing Day, 26th, and that actually corresponds to an annular eclipse of the sun. And we have full moon coming up on January the 10th, which corresponds to a penumbral eclipse of the moon. We also have the Geminids, great meteor shower, coming up on December the 14th, very close to the full moon in December, which is a bit of a pain for us meteor observers. But I'm always amazed by the kind of images that people can get. I get even more and more amazed by the images that Damien Peach can get, although he does have access here to a 1-meter telescope. So this is the Chilescope that he now uses. So his poor 14-inch Celestron obviously is not really cutting the mustard anymore, so he's using this 1-meter telescope. And basically, this is now moving remote observing from deep skies to planet as well. So as I understand it, essentially there's a PC there in Chile that does all the video collection, and he does all of the processing locally in Chile on that machine using remote desktop, so that you don't have to bring the gigabytes of video back. But this is a really extraordinary picture, and it kind of, I remember when I was a lad, the kind of picture of the century was a picture taken by the Lunar Orbiter spacecraft, which was looking obliquely over Copernicus. And just the details you can see in these ramparts here is quite extraordinary. Really amazing stuff. So yeah, this is the eclipse coming up on Boxing Day. Anyone going to see this one? I thought probably not. There are a few people who do actually travel even to see annular eclipses. So this is one of those eclipses where the moon is near apogee. And of course, at this time of the year, the sun, we're near perihelion. So the sun's almost as big as it can get, and the moon is quite small, so it doesn't fully cover the sun. So this is an annular eclipse. It starts at sunrise in Saudi Arabia, crosses the UAE and goes into Oman, and then heads out over the Indian Ocean here and eventually ends up in the Pacific. So there will be a few people who go to see this. Most of them will be situating themselves somewhere around Oman or around there to get the ring of fire at sunrise. There's also a lunar eclipse, penumbral eclipse, nothing really exciting. The moon doesn't actually get into the Earth's umbra, but it does fit in the penumbra. This is visible from the UK on the date of full moon in January the 10th, in the evening, so about 7 p.m. If you go out and have a look at the full moon, it won't be quite as irritating as it normally is. It'll be a little bit fainter because it's in the penumbra. Of course, the big event that's happened recently is this. How many people saw the Mercury transit? A goodly number. That's not bad. Given how rubbish the weather was over the UK, I think people have been pretty lucky in managing to get cloud gaps and managing to pick up the transit. It's the last one, I think, till 2032. Is that right? I think when the next one is. So you know, we were lucky to actually get to see it, and we've had some really nice pictures submitted to the BAA. I haven't really got time to show all of them, but I just wanted to run through a few. This really nice sequence from Nick Quinn at Ingress, showing Mercury moving onto the disk of the sun. And you really realize when you see Mercury against the sun what a small planet it is. I mean, it was just over 10 arc seconds in diameter, moving on to the face of the sun. And of course, that's as large as Mercury pretty much ever gets, because we're seeing it in line with the sun there. Nice picture here from Richard Petrie a little bit later as it had moved onto the disk. On a Wheeler, managed to get this with an aircraft flying across the sun and Mercury there. And that's a kind of really nice demonstration of the perils of imaging the sun in the southeast of England. Of course, if you use hydrogen alpha, you can get a little bit more detail. You can see granulation on the sun here. So this is a really nice image. And then this one, of course, on the cover of the current journal, Ella Bryant's picture showing a prominence and Mercury on the disk at the same time. So imaging, lots of really nice images, not so many visual observations, but as you'd expect, Paul did this drawing from, I think with Pete Lawrence you were, weren't you?
He said I brought the clouds with me.
Yeah, well, that's possibly true, but you actually managed to get, did you actually see Ingress, or did you see?
Yeah, that was really pretty much
that was your first view.
Try and get it against a little layer.
Yeah.
The clouds didn't clear in time, so.
Right.
But that's about the closest I got.
Very nice view, and good to have a visual representation of this transit. I thought I'd stick this one in on a claim that her plane was fully on the disk. My plane here is not quite fully on the disk, but I've used this in a couple of things I've done with schools to do some kind of physics lessons about the sun's 150 million kilometers away, Mercury about 100 million. And if you know the length of an MD-11, which us geeks know that is, you can work out how far the plane was away. It's about 35 kilometers away and about 30,000 feet. So there you go, bit of geometry there. And then Gary Gawthorpe sent this one through, and I thought, oh, he's got the image upside down, until I realized that actually this was taken in Florida. So in Florida, he could actually see the egress. So this is, I think, about the only image we have on our website which shows the egress. So Mercury went through its transit, and then it's done a brief display in the morning sky. So if you get up in the morning sky, you'd have seen, and you had a good eastern horizon, you'd have seen Mercury looping up. It moves so fast around the sun, it's gone now, but this is our current picture of the week on the BAA website. This is Leo Aerts' picture of Mercury. This is an image of an object that's just over 6 arc seconds in diameter. And I think it's just extraordinary that you can get that kind of resolution on an object of that diameter. I think it's one of the most amazing pictures of Mercury that I've seen, actually. If you wait a little while to the end of January, Mercury will do its little loop again, so you have an opportunity to see it in the evening sky. But the main thing in the evening sky that we're seeing at the moment, of course, is Venus. Venus coming up from the horizon, moving gradually north as Saturn is moving in the opposite direction. And they pass each other, I think December the 10th, 11th is the closest. If you look on the BAA website, that's one of our observing challenges at the moment. So if you do manage to get some nice images of Venus and Saturn passing each other, please send them in, put them on the members' pages of the BAA. It's a good way of displaying what you're doing and also sharing your work with other people. A time lapse would be quite good to do as well, but of course that would need you to have clear skies every evening for the next 2 weeks. I think that's probably fairly unlikely. Saturn, of course, is now moving towards conjunction. Again, this is an amazing image that Damien sent in, taken with that 1 meter chilescope, which shows extraordinary detail again. But Trevor Barry's image is not bad as well. I mean, that's really good. But we've pretty much lost Saturn now as it moves in towards conjunction, the same with Jupiter. So really it's Venus coming up over the next few weeks that it'll be a good planet to observe in the evening sky. And we've had some pretty good pictures sent in, this one from Peter Meadows, and this one from Tim Hames. When I first looked at it, I thought it was buffalo. But there's not many of those roaming free in Oxfordshire. They're actually sheep. But you could believe they were possibly buffalo. There are 2 planets that are fairly well visible actually in the sky in the early to late evening. That's Uranus and Neptune. And this is a rather nice image of Uranus taken by Chris. What would be, it's about 3.5 arc seconds, I think, something like that, Uranus. So again, amazing that you can actually get such imagery with amateur telescopes. Now, there has been a little thing with Neptune recently, and I do apologize to the professional astronomers who are in the audience, but there is a website called the Transient Name Server. And this is a website that professionals use to announce discoveries, supernovae, nova, that kind of thing. And there's a professional survey called MASTER, which announced the discovery of an 8th magnitude transient object in Aquarius. And this being professionals, it wasn't just one person, it's basically half a university who appear as the author list. Now, you'd have thought that one of this huge and this no doubt very esteemed group of people might have checked what this 8th magnitude object in Aquarius was. Anyone want to have a guess? Neptune. So Robin very politely posted on the TNS, Neptune, ? And of course it was. So there you go. As far as I know, the master team haven't posted any follow-ups or no apologies or anything. You may remember that a couple of years ago there was an event where a guy in South Africa, I can't remember his name off the top of my head, discovered Mars in the Lagoon Nebula or something, wasn't it? As a bright transient there. So, you know, at least he was quite good about it. He got a certificate, actually. Anyway. Well, indeed, yes. So there you go. At least as amateurs, we're allowed actually to post. They trust us as amateurs, if you're registered, to post to the TNS. We're not allowed to post to the Astronomer's Telegram as amateurs, as I understand it, because we're obviously not, trustworthy enough. And that's where the discovery of Mars was announced. Anyway, Terry Evans' picture there of Neptune, Triton, and Phi Aquarii. So if you do discover anything bright in Aquarius, do just check it's not a planet. Urban Liberia probably got there before you did. Anyway, in terms of discoveries, you may not be aware of this because it hasn't been that well publicized so far, but the BAA has started up a new system to distribute alerts to people. We used to have an email system, but for technical reasons, that was withdrawn. We now have a system called BAA Alerts. You can go to the website, you can sign up for that. There hasn't been much traffic yet, but the idea is that section directors can use it to announce anything that might happen to be coming up in the sky as an alert system. So I recommend you go along and register for that. Right, in terms of things near the Earth, the ISS is up there at the moment. We've got some good passes of the ISS. This is a really good one, which happened about an hour ago. But there's good passes tomorrow as well. And of course, yesterday, our friend Elon Musk, or a few days ago, launched SpaceX CRS-19, which is going up to rendezvous with the ISS. If it had been clear tonight, you may have been able to see both of them go over together. By tomorrow night, they should have actually docked. But if you can take images like this, and these amazing images by Chris Hooker, taken with a telescope and a high-speed camera, show amazing detail on the space station as it comes over. And you might think that that's you need really advanced equipment to do that. But there are these images, these are, I think, from a couple of years ago, but these are from Tim Burgess. And what these are is he had an 8-inch Celestron with a Canon camera operating in video mode on the back, and he just manually tried to follow the space station. And every now and again managed to get some good video of it. And it's amazing what you can see, even with that kind of very simple approach. Right, so the next bit is where I've got to be a bit careful about what I say about Mr. Musk and his associates. You will recognize, I think, these objects. These are the first launch of 60 Starlink satellites. They were sent up in May. This is just after they'd been released, about a day after they'd been released by the rocket. So the rocket they're launched on, Falcon 9, has a payload capacity of about 24 tons, which means it can launch 60 of these 380 kilos satellites up into space. So SpaceX plans are that these will be used to provide internet connections around the world. The first plans are basically to fill up low Earth orbit with about 4,800 of these things, and then move into higher shells as well. That's going to involve a lot of Falcon 9 launches, and it's going to involve a lot of these spacecraft being up in orbit. And as amateur astronomers, one of the things we worry about is what that's going to do to the night sky. Now, it is true that these things are only a problem when they're actually visible in twilight, but the trouble for us at our latitudes is twilight lasts most of the night through the summer, so we'll be seeing them a lot. This is Sierra Tololo. This is then visible in the night sky there. Not that long ago, a couple of weeks ago, the second batch went up. So bear in mind, there's only 2 batches now. This is the Falcon 9 launch a couple of weeks ago. This is another 60 of those satellites going up. There's going to be another 160 odd launches, something like that, of this to fill up LEO with it. And these are all the spacecraft. So each of these is about 350 kilos. They get pushed off, and then they spread out in orbit. They have ion thrusters that allow them to raise their orbits to their operational altitude. And we're already seeing the results of these in a lot of astronomical images. This is what our Meteor cameras saw a few days ago. This is William Stewart's camera at Ravensmoor. This is Clanfield, so you can see them moving there. The next one will be my camera in Chelmsford. You can see them moving up here. And then Alex Pratt's camera, which you'll see in a sec, you can see them moving across the sky. So these objects are going to become more and more of a problem. And I think as astronomers, there's probably not a lot we can do about it. It seems to be pretty much a free-for-all as to what people can launch. The practicalities of making these things darker is very difficult given the thermal requirements that the spacecraft has. So I think from an imaging point of view, we're going to have to just rely on more and more clever software that can somehow detect and remove these from our images. But it's not just visual stuff, radio as well. This is meteor radio detection using graphs. This is William Stewart's detection of about 60 of these Starlink satellites as they went across. So I'm afraid they are going to become more and more of a problem, and we are going to have to somehow adapt to deal with them. Professional observers have got problems too, but in many cases they are closer to the equator, so they have less of a problem than we do far north. But unfortunately, having had to battle with terrestrial light pollution, I think we now have a situation where we're going to have to battle with these spacecraft as well. Another thing we have to battle with is the media. I get all of my astronomical news from the Daily Express, as I'm sure we all do. This is an example of actually relatively sane reporting. Talking about an asteroid pass, although it did say it was going to come dangerously close being 6 million kilometers. But David Swan got a really nice time sequence of it. How good are you as observers? Could anyone spot the asteroid on this sequence? I'll give a raffle prize to anyone, or one of the old raffles. See, I can't even find it now. Oh. There it is. Yeah, okay. So as an example, though, of how things in the media have just reached a state where you can't believe anything you read in the media. One of the things as an engineer I find incredibly annoying is that as engineers and scientists, we've spent hundreds of years trying to come up with an internally self-consistent of units for measuring distance, velocity, volume, whatever, which the media can't use. Everything has to be in the size of double-decker buses, but this goes to an extraordinary thing. It says, this is talking about an asteroid, it says, even at the lower end of the estimate, the space rock is believed to be 9 times as long as a queen-size bed and about 3 times taller than an average giraffe. So, I'm not sure that helps, really. I mean, I know vaguely what a queen-size bed is, but there aren't many giraffes that roam the streets of Chelmsford. So thank you, Daily Express, for that. Now come on to something much more serious, variable stars. Woo! Cheers from the audience. So there are really two nice binocular variable stars that are worth having a look at over the next month or so. This one, Chi Cygni, which is very well placed in the evening sky in Cygnus at the moment, and it's coming up to its maximum. So it'll probably reach about 5th magnitude, something like that at maximum, Gary, that kind of thing. And that's due in January. So that's a star that's definitely worth having a look at, making some estimates of with binoculars. And there's another one which we all know very well, our Corona Borealis, which is a little bit more, needs a bit more effort at this time of year because it's a morning object. So it needs you to get up fairly early in the morning. And here it is, it's just recovering from its fade, but it's still reasonably active. If you look south at this time of the year, of course, we see all the winter constellations, Orion, Gemini, lots and lots of interesting deep sky objects in this region. And then sort of above us as well, we've got Cepheus. And not only do we have variable stars, but we have variable nebulae. And I'm just going to mention a couple here that are worth looking at. This one, Gabaldaggian's Nebula, which is illuminated by the variable star PV Cephei, is currently looking rather sorry for itself, rather faint, but definitely worth keeping an eye on. And then the other one, McNeil's Nebula, which is in Orion, just south of M78, has pretty much disappeared altogether. So again, another variable nebula to keep an eye on to see when it might come back. And of course, there are some really lovely deep sky objects in the winter. This picture of Rosette Nebula, I think, is particularly wonderful because it was taken from Stanmore in Middlesex. And it shows that with the kind of, even with the kind of light pollution that we have to deal with, if you have the right techniques and the right filtering and the right equipment, you can get amazing pictures. But this picture of Graham Winstanley's as well just shows an amazing amount of the outer detail of an object that we all think we know very well, M42, but which every year I still have a go at imaging, because every time I look at M42 with maybe a new piece of equipment, I see something new. Meteors, we've got the Geminids coming up on the 13th, 14th of December. They've already started, but the peak's around the 13th, 14th of December. Unfortunately, they are at their peak pretty much at the time of full moon, so there will be a problem this year. But this bit of video here is a Geminid from a couple of years ago, taken with my Sony Alpha 7 camera and a nice fast lens. And there are now so many different video systems looking at the skies for meteors that we're collecting a huge amount of data on meteor showers. But even if you just want to do visual observing, that's still important to do. In the case of the Geminids, you'll just have to make sure that you try and get the moon out of your field of view behind something. It'll be quite high up, unfortunately. In fact, on maximum night, it's in Gemini. So it's about as bad as it possibly can be. The alternative is the Quadrantids, which are around in early January. Moon's conditions much better for those. The Quadrantids have a very narrow peak, but if you do get clear skies on January the 4th, and that's at least long enough after New Year's Eve that you should have recovered by then, get out there and have a look at the meteors. So then, sort of coming to the end, I haven't mentioned comets yet, and that's because, unfortunately, as Comet Section Director, I haven't actually managed to serve up any really bright comets. Unfortunately, no comets like these two. We've recently started putting archival images in our Comet Section archive. So these are scans of material from a long time ago. The one on the left there is the famous comet from 1957, Comet Arend-Roland. And the one on the right is Comet Vest from 1976. So sadly, we don't have any comets quite like that. The brightest comet that we do have around at the moment is a comet that was discovered by Pan-STARRS in 2017. And it was a long, long way out when it was discovered, and it was about 20th magnitude. And it's been brightening slowly. It's coming into perihelion next year in May. But it has a big advantage for us that it's circumpolar at the moment. And it's actually passing through a number of constellations we're very familiar with. So it's currently in Perseus. It'll head through Cassiopeia. It heads very close to the double cluster, which you can just see sort of north of Perseus there. So very close to the double cluster towards the end of January. So quite a nice potential photographic target. It's not hugely bright, but it's something you can pick up with relatively small instruments. It's probably about 9th or 10th magnitude at the moment visually. It'll probably peak maybe 8 or so visually. There's quite a discrepancy between what visual observers see and what imagers get. But it's got a nice tail. This is a movie I did of it a few days ago. And in fact, again, to see if there are any really good observers in here, there's an asteroid moving in this frame as well. Can anyone see it? Yeah, so there it is. So that's an asteroid that I think was about 15 million kilometers away or something at the time. But I'll just run quickly through a few pictures. This one from Peter Carson, I think must have been one of the last ones that Peter did before abandoning the observing site in Southend and moving to the south of Spain. It's passed some really nice deep sky objects. So this one from Martin Moberly here, as it was passing by, which open cluster was this? M36. Okay, I can do the comets, it's just these kind of weird stationary star patterns. Denis Bozinski, an image from up there. And then Steve Arnold has now started taking some really good images of comets. And Dave Eagle here, a color image. So keep an eye on that comet through the winter. It'll be well placed for us all. It'll be brightening slowly, definitely something to have a go at. Finally, on the comet front, there's this one, which I wrote a short article for in the last journal. This is Comet Borisov. This was discovered by Gennady Borisov, this guy here, using I think a 0.3 meter, very fast Hamiltonian telescope, so specially designed for comet discovery. It looked like a fairly boring comet when it was discovered, but when its orbit was computed, it's actually got an eccentricity of over 3, which means it's actually come in from outside of our solar system. So this is the second only confirmed interstellar visitor we had. We had Oumuamua a year or so ago, which was more asteroidal. This is definitely cometary. It's on an orbit which is diving down through our solar system. It's just about coming to perihelion now. It comes to perihelion in December, and it's reaching about 15th magnitude. It's in crater, though, at the moment, so you need a more southerly telescope to get some imaging of it. But really an amazing object, and the fact that amateurs, we can get images of objects like that, you know, lumps of ice that have come from other solar systems. Thanks to Martin Mobley, this is an image from yesterday using the Eye telescope. So unfortunately, I can't promise you any bright comets. But if we did rely on the media to tell us about bright comets, this was another great one. This is the Daily Mirror, unparalleled in its science coverage. Huge comet will fly past Earth this week, and there's a chance you could see it. So this was a few months ago, and it's about a comet called 168P, Hergenrother. At the time that this article was written, the comet was about 20th magnitude. So just to wrap up, I thought I'd put up this rather nice Christmassy picture and ask if anyone could guess what this actually is. Sirius. It is Sirius. So this is a Gordon Mackey picture of Sirius taken with a lens that he just wobbled around. So while Sirius was sitting there twinkling and scintillating in the sky, you see all of the colors of Sirius. So I think this is really neat as a kind of just a clever thing to do with a camera system. So that's our Christmassy picture. So thank you very much. Happy Christmas to everyone. Safe trip home. Don't forget that comet, and don't forget all of the other things too. But Venus and Saturn conjunctions, and the Geminids too. So happy Christmas, everyone. See you next year.